Hi class, today we're looking at Chapter 8, Lesson 3, Inferences. You can use data from a random sample of a population to draw inferences about the entire population. When you draw an inference, you make a prediction or conclusion based on data or reasoning. Let's write that down. So an inference is when you make a prediction or conclusion based on data or reasoning. So we're going to look at drawing an inference about a population. A restaurant manager selected a random sample of 20 customers and recorded the amount they spent at their meal. Based on the sample, which is the best estimate? What is the best estimate of the average or mean amount that customers spent on a meal? So here is the chart. Oh, I think it's kind of cut off there. Oh no, it's good. So our first step is find the average or mean. Those words are pretty interchangeable of the sample data. So to do that, we take the mean and it equals the sum of the data and the number of data values. So that means that we are going to add up the sum of the data, add up all of these numbers, every single one, and then you're going to divide by the number of numbers we have. So if we were to add all these numbers up, use your calculator, you get 320. And there are 4 times 1, 2, 3, 4, 5. So write 4, 8, 12, 16, 20. There are 20 samples. The number of the data values is 20. When we divide those, we get 16. So therefore the mean equals 16. That's the average. The average that somebody spent at the restaurant is $16. So use the average of the sample data to draw an inference. Oh, and so I kind of just said that. So the average amount spent by a customer sample is $16. So the average amount spent by all customers is likely to be $16. Let's write that down. So the average spent by customers in the sample is $16. So the average spent by all customers is likely $16. So this is the same chart. So using that same chart, draw an inference about the percent of customers who spent more than $20. Think about that. Try that on your own. Come back to me when you're done. Okay, so by solving this, I did 4 over 20, 4 out of 20 people spent more than $20, and I turned it into a percentage proportion, and I got x equals 20, so therefore that means 20%. So the answer needs to be in written form. So in the sample, 20% of customers spent more than $20. So it's likely 20% of all customers will spend over $20. That word likely is key because it's, giving some leeway and making it known that it is a prediction based on data. So just to be clear, the different random samples from the same population may give different results, By comparing the samples, you can determine how much estimates or predictions made from the sample will vary. So here we have a study. There were 360 students at a middle school. Sonia, Jane, and Danny each surveyed a random sample of 25 students about whom they'd planned to vote for in the election for student council president. Their results are shown on the table. For each sample, predict how many votes Carlos will get. So this is the first question. So to do that, we're going to use a proportion. We're going to take the votes for Carlos in the sample and divide it by the students in the sample. And that's going to equal the predicted votes for Carlos and the students in the school, for the number of students in the school. So let's do that for each of these. So let's start with Sonia. So she said that there were 12 votes, and the students' sample was 25. And so the predicted votes is what we're going to find out because the student population is 360. So we multiply the 12 times 360. And that equals 4,320 equals 25x divided by 25. So that equals about 173 votes. And these are my wiggly equals that weren't very good. Oops. So then let's look for Jane. 13 over 25 equals x over 360. And that's going to equal 680 equals 25x divided by 25. So that's going to be about 187 votes. And the last one, Danny, got 15 out of 25. So that equals x over 360. Multiply 15 times 360. 5,400 equals 25x. Divide by 25. 216. So, describe the variation in predictions. So to do that, you often will say the greatest and the least. So we're going to put the greatest prediction is 216. The least prediction is 173. And then we want to subtract these. So, and that when you subtract 216, subtract 173, you get 43. So So predictions vary by 43 votes. There's going to be a lot more writing words in this section, this lesson, than you're used to. Okay, so then it says, draw an inference about the number of votes Carlos will get. So if you were to think about the middle number, that's going to be the median. And the median is oftentimes the number that you'll go with. So that our inference, our conclusion, is going to be Carlos is likely to get about 187 votes. And that's the median, the middle number, prediction. Okay, get that written down. Okay, so now quick check. Look this over. The table shows the results of 3 random samples of 30 students, each at a middle school with 420 students. The students were asked how many hours they spend online each week. So I want you to work through A, B, and C, just like we did above. Press pause. Come back when you're done. So you should have got the 3 different predictions of how many students in the whole school would be using the computer online, and making sure you used these samples because this is 5 or more, and it said at least 5 hours. Okay, so based on that, the greatest was 266, the least was 196. They vary by 70 votes. It's likely 238 students spend at least 5 hours a week online, the median prediction. So now we're going to look at number 2 because it's similar to what you'll be doing for number 3. So this says a population size is 275. Sample 5 out of 45 have white eyes. So set up your same equation we've been doing. So 5 out of 45 equals equals what? X out of 275. Okay, so we just cross multiply. So I did 275 times 5, got 1,375. Divide that by 45. X equals 330.5555. So I'm going to round. 5 makes it round up. I'll just put this down. So 5 makes it go up, therefore 31. So about 31 of the whole population should have white eyes. So the mean is the average. And to get the mean, add all the numbers together and then divide that by how many numbers you have. What is the median? The median is the middle number. Okay. Hope that helps with your homework questions. Your homework for today is page 294 and 295, number 3 through 13 odd. Happy homeworking.